Yeah, hello guys. We are discussing about mesh analysis. In my previous video, I have explained about what is mesh analysis, then what is the procedure of mesh analysis to find some unknown parameter in the circuit. And at the same time, I have explained about a few problems that how to solve by using mesh analysis. Now in this video also, I'm going to explain another problem. Now before apply mesh analysis, now you need to understand, can we apply mesh analysis or nodal analysis to this circuit, right? Now, in order to conclude that, you need to understand, you need to find how many voltage sources and current sources we have. We have three voltage sources, of course. If any circuit is having more number of voltage sources, then you can apply mesh analysis. Okay. Now, point number two, is it a planar circuit or non-planar circuit? Yes, it is a planar circuit because it doesn't have any cross over, okay, for the elements. Then if it is a planar circuit, you can apply mesh analysis. Clear? Now before apply mesh analysis, you need to understand that how many closed loops we have. So closed loop or closed circuits we have. So in this particular circuits, you have three closed loops. So if you have three closed loops, then you can find three currents, three loop currents, I1, I2, I3. Suppose if they don't give any current direction, you can assume the current direction. That current direction may be clockwise direction or anti-clockwise direction. For example, in this circuit, they have given a I1 clockwise direction and I3 is also clockwise direction, whereas I2 is what? Anti-clockwise direction. But I am not interested with the anti-clockwise direction. Let us consider this I2 is also flowing like this. This is also clockwise direction. Now you need to find mesh current by using mesh analysis. Now I need to apply what? Apply KVL in loop 1. So before apply KVL in loop 1, what should I do? So based on the current direction, I need to consider higher potential or lower potential to the each branch except sources. Now I1 is flowing like this, therefore this is plus to minus. I1 is flowing like this, therefore this is plus to minus and plus to minus. Now if I apply KVL, you already know about KVL, right? KVL, it states that the algebraic sum of all branch voltages in a closed loop, branch voltages in a closed loop is equal to 0. Now here I need to keep plus or minus. Here minus to plus, current is going from minus to plus, therefore plus 50. This is the voltage of this particular source. Now here plus to minus, what is the voltage at 10 ohm resistor? You can find voltage by using Ohm's law, V equal to IR. Now what is the R? 10. And what is the I current? Current I1 is flowing as per our assumption, minus 10 I1. Now here when you come to the 5 ohm plus to minus, at 5 ohm resistor, two currents are flowing, I1 and I2, in the opposite direction. Yes or no? Opposite direction. Therefore, 5 and opposite direction means what? I1 minus I2. Therefore, when you come to the 3 ohm resistor, plus to minus 3, and two currents are flowing in the opposite direction. I1 is coming from top to bottom and I3 is going from bottom to up. Therefore, I1 minus I3 equal to 0. Now you need to simplify this one. Therefore 50 minus 10I1, and if you multiply minus 5 inside, minus 5I1 plus 5I2. If you multiply minus inside, minus 3I1 plus 3I3 equal to 0. You always need to write I1, I2, I3 and constant terms. So here minus 10, minus 5, minus 15 and minus 3, minus 18I1. And what are the I2 terms here? Plus 5I2, and you have only I3 term is what? 1, that is 3I3, and plus 50 equal to 0. Can I multiply with minus to the whole equation? Yes. 18I1 minus 5I2 minus 3I3 minus 50. This minus, if it goes to the right hand side, that is what? 50. Therefore this is what? Equation 1, and equation 1 I have get after applying KVL in equation 1. Therefore 18I1 minus 5I2 minus 3I3 equal to 50. Now if I apply KVL in loop 2, so before apply KVL in loop 2, what should I do? Consider or assume that potential to the each branch. current is going like this, therefore this is plus to minus, and here plus to minus. You should not change potential for the sources, only elements. So for 1 ohm this is plus to minus. Now here for 5 ohm resistor, plus to minus 5, what current is flowing? I2 and I1, opposite direction. So I2 minus I1. Suppose if it is going in the same direction, you should write I2 plus I1, opposite I2 minus I1. Therefore here when 2 ohm resistor minus 2, what current is flowing? Only I2 minus 2I2, and this is the source plus 2 minus 10, and here we have 1 ohm resistor minus 1, and you can write I2 minus I1 because these two are flowing in the opposite direction, I2 minus I1. Clear? Now you need to multiply this minus 5 inside, minus 5I2 plus 5I1 minus 2I2 minus 10 minus I2 plus I3 equal to 0. Now you need to write I1, I2, I3 and constant values. So 5I1, and what are the I2? Minus 5 minus 2 minus 7, and here minus 1 minus 8 I2 and plus I3. Here we have minus 10. If it goes to the right hand side, you will get what? Plus 10. This is what? Equation 2. So equation 2 you get after applying KVL in loop 2. Okay, clear? Now you need to apply KVL in what? In KVL in loop 3. Okay. Now before apply KVL, you need to assume the potential to the each branch. So current I3 is going like this, therefore plus to minus, and the current is coming plus to minus. So you should not change potential to the sources. Therefore for the 3 ohm resistor 3, now I3 I1 is flowing at a 3 ohm resistor, therefore I3 minus I1. And now for coming to 1 ohm resistor, plus to minus minus 1, and I3 I2 are going in the opposite direction, I3 minus I2, and here for the voltage source minus 5 equal to 0. Therefore if you multiply inside, minus 3 I3 plus 3 I1 and minus I3 and plus I2 minus 5 equal to 0. Always need to write I1, I2, I3 and constant values. So 3 I1, and how many I2 terms we have? Only one, I2, and you have minus 3 and minus 1, therefore minus 4 I3. So this minus 5, if it goes to the right hand side, this is plus 5. Therefore this is our equation 3. The equation 3 is what? 3 I1 plus I2 minus 4 I3 equal to 5. Clear? Now see, we have 3 equations and you need to find I1, I2, I3. So by using what? Cramer's rule. So by, as per Cramer's rule, I1 equal to what? Delta I1 by delta, and I2 equal to what? Delta I2 by delta, and I3 is delta I3 by delta. Now you need to find delta I1, delta I2, delta I3. Okay, that means the determinant of delta by using Cramer's rule. So here delta means what? I1, I2, I3 terms from equation 1. So what are the I1 terms? 18 and minus 5 and minus 3. This is the first row. Okay, I1, I2, I3. Now from equation 2, you need to write I1, I2, I3. Therefore 5 minus 8 and 1. Now from equation 3, you have to write I1 coefficient, I2 coefficient and I3 coefficient. So this is my delta. Now what you need to do? You need to find the determinant of this delta. So you know, right, how to find the determinant of delta? If I keep 18 here, now you should not consider this entire row and column. Therefore here you will get minus 8, 1 and 1 minus 4. Now here you have written plus. Next one you need to write minus. Correct? So already you are having minus 5 here. Minus minus will become plus 5. Now if you consider 5, you should not consider this entire row and entire column. And what are the remaining elements? 5, 1, 3, minus 4. Now you need to consider 3. So plus, minus, plus. So however here you have minus, plus into minus will become minus 3. Now if I consider 3, you should not consider this entire row, entire column. And what are the remaining 2 by 2 matrix? 5 minus 8, 5 minus 8 and 3, 1. Okay, clear. So this is the way of writing for the 3 by 3 matrix in order to find the determinant. I hope you know how to find the determinant of this, right? So if you don't know how to find the determinant for the 3 by 3 matrix, so please visit my previous video that I have explained how to find determinant for 2 by 2 and 3 by 3 as well. So just for time saving here, I am going to return the direct determinant of delta. Therefore, delta you get here 356. This is the determinant of delta. So if you solve this one, you will get delta is what? 352. Then here I can write delta I1. So how can I write delta I1 here? So simply, so here you have what? This is what I1 terms. These all are what? I1 terms from equation 1, 2, 3. And here this all are what? I2 terms. And this is what? I3 terms. Now what you need to do in order to writing delta I1, instead of all I1 terms, you need to write the constant values from equation 1, 2, 3. What are the constant values here? We have 50, and from equation 2 you have 10, and from equation 3 you have 5. Yes or no? Yes. 50, 10 and 5. Now the remaining I2 and I3 variables or coefficients are same from the delta. So here minus 5 and minus 3, and here minus 8, 1 and 1 minus 4. Now you know how to find the determinant of delta I1, right? So the same as delta. Now if you find the determinant of delta I1, therefore the delta I1 determinant is 1175. Now in order to write delta I2, what we need to do? Now instead of I2 terms, you need to write the constant values. Okay, you need to write the constant values. What are the constant values? 50, 10 and 5. So the remaining I1 and I3 terms are same as delta. So here I1 terms are what? So 18 and 5 and 3 from equation 1 to 3. And what are the I3 terms from equation 1 to 3? Minus 3 is the I3 term from equation 1, and from equation to 1, and from equation 3 minus 4. Therefore, I can write minus 3, 1 minus 4. So if you find the determinant of delta I2, okay, by using the same calculation, you will find the delta I2 equal to 355. Just for time saving, I'm writing the direct answer. Now you need to write delta I3. Okay, now what you need to do? Instead of I3 terms, you need to write what? The constant values from equation 1 to 3. Now what are the constant values? 50, 10 and 5. Okay, 50, 10 and 5. Now see here, what are the I1 and I2 terms are same. What are the I1 terms here? 18 and 5 and 3. And what are the I2 terms? Minus 5, minus 8 and 1. So if you find the determinant of delta I3, therefore here you will get what? 525. 525. Now you know the determinant of delta, and you know the determinant of delta I1, delta I2 and delta I3. Can we find I1, I2, I3? Yes. Therefore, I1 equal to what is the formula? Delta I1 by delta. So here what is delta I1? 1175 by delta means what? 356. So if you calculate this one, you will get what? 3.30 ampere. Now what current is flowing in the loop 1? I1 current. What is the I1 current value? You can say this is 3.30 ampere. Now what current is flowing at 10 ohm? 3.30. Therefore the current at 10 ohm is what? 3.30 ampere. Now you can find I2 current. The formula is delta I2 by delta. Therefore delta I2 determinant is what? 355 by, and here this is what? 356. Therefore I2 equal to what? 0.99 ampere. And the next one, I3, delta I3 by delta. Therefore determinant of delta I3 is what? 525, and delta value is what? 356. Therefore if you cancel this one, you will get 1.47 ampere. Now see here, by using mesh analysis, you find the mesh current I1, I2, I3. So what is the use of this mesh current? Once if you know the mesh current, you can find whatever the parameter you needed in this circuit. For example, if you want to know what current is flowing at 2 ohm resistor, now what is this 2 ohm here? Now what current is flowing as per our assumption? I2. Now what is the I2 current? 0.99. See, you can find current at 2 ohm resistor. Once if you find current and you already know what resistor equal to what? 2. Can you find voltage V equal to IR? So if you submit 0.99 into 2, you can find voltage. So once if you know voltage current, you can find power at 2 ohm. Now see, what is the current at 1 ohm resistor? If you as per I2, the current is flowing what? I2 minus what? I2 minus I3. This is what the current at 1 ohm. Now you already know I2 current and I3 current. Then if you subtract, you can find the current flowing at what? 1 ohm resistor. Once if you know the current, you can find voltage, you can find power at anywhere in the circuit. Okay. So this is all about mesh analysis. I hope you understood this concept. Thank you. Thank you so much.